Okay. I'm going to go through this as fast as I possibly can because I just realized this morning that I forgot to go back and do this on Friday. I'm so used to having it done before class. I forgot that I didn't have time to do it before. So if we just take some binomials and raise them to different powers, if you take something to the 0 power, as long as it's not 0 to start with, you get a 1. A plus b, the first is a plus b. A plus b all squared. That's a squared plus 2ab plus a b squared. Because remember, you're doing a plus b times another a plus b. A squared, ab, b squared. If we want this one, we're doing this. These two, we just wrote down what that is. So if we multiply that out, let's see what we get. I'm just distributing. We'll keep it alphabetical order. All right, so we get the a cubed. There's 3 of the a squared b's. There's 3 of the ab squareds and a b cubed at the back. All right, if we want a plus b to the 4th, okay, then let's think of it this way. That's that times this. So we'll take what we just found. Times it again. Okay, so there's definitely the a the 4th. 4 of these. 6 of those. 4 of these. And a b to the 4th. Okay, so look at our answers. And particularly look at the coefficients. 2. Put in the ones you can't see. So if I asked you what a plus b all to the 10th is, yeah, that would be kind of miserable. We don't want to do that. But there is a huge pattern. I don't know if pattern is the right word. I guess it's a pattern. But all those coefficients, when we expand binomials, they come about from something known as Pascal's triangle, where you start with a 1, and 1 is next to nothing, so 1 and nothing added to 1, 1 and nothing added to 1. 1 and nothing added to 1, 1 and 1 make 2, 1 and nothing make 1. So what I'm doing is I'm adding the number with what's next to it, and then like putting the sum in between those two numbers. So 1 and number on the next row. 1 and nothing's 1, 1 and 2's 3, 2 and 1's 3, 1 and nothing's 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Like I can sit here and do this all day. But these are the coefficients of each of these rows, like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And if you look at what's going on with the powers, if it's to the 4th power, you always, whatever the front term is, you start out with all 4 of those. And then it loses a power every time until there aren't any. But whatever the second term is, you start out with none of those and you gain 1 every time until that's all there is. So I don't want to sit here and go a plus b all the way to the 10th, but I got to this row. So if I wanted a plus b all to the 6th, I'd have 1 of the 8 to the 6th. I'd have 6. All right, I'm going to lose 1 on my A, but gain 1 on the B. Plus 15 A to the 4th B squared. Plus 20A cubed B cubed. Plus 15A squared B to the 4th. Plus 6AB to the 5th. Plus 1B to the 6th. So it's kind of cool that you don't have to multiply the whole thing out, because that gets kind of old. And there it sits. So if we're doing x plus y all to the 7th, I'll just come up here and expand this a little bit more. We'll get to the row where the first number that's not a 1 is a 7. So if I'm just looking, it's just x's and y's. So I start out with 1 of the x to the 7th plus 7, lose a power on the x, gain a power on the y, plus 21x to the 5th y squared, plus 35x to the 4th y cubed, plus 35x cubed y to the 4th, plus 21x squared y. And here's, if you kind of lose track, these powers always add up to 7 to the 5th, plus 7xy to the 6th, plus 1y to the 7th. Okay, now these are a lot easier because we just go straight to the answer. It's just a plain old x plus a y, a plus a b, n plus a g, whatever they are. So, but if you've got something in here that's not just a plain variable, just x or y or z, you still do it the same way. You just have some work to do after you get it set up. So I'm going to go to this row of Pascal's triangle. I've got, and I don't know if y'all noticed this or not. When it was raising to the 4th, you ended up with 1, 2, 3, 4, 5 terms. When it was to the 3rd, you had 4 terms. Whatever the power is, you're always going to have one more term than that. So if I'm raising this to the 3rd, I know that we're going to end up with 4 terms. I know the coefficients because I get those from Pascal's triangle. I know whatever I start with, it's going to start out cubed and then drop to a square and then drop to the first, and then it'll have none of them. And whatever second will start out with none of them, gain 1, gain another, and then have all of them. It's just my first term in that binomial is a 3y. And the back term is a 1. So it's just I take each of these individually, like 3 cubed, that's 27y cubed when I clean that term up. Plus, okay, so 3 squared is 9 times 3 more is another 27y squared, plus 9y plus 1. Okay, now if it's a minus sign, like everything that we've done with this pattern, it was something plus something else, something plus something else. If it's a minus, you can still think of it that way. It's an x plus a negative 2. So you got to think like that. So we're going to make our Pascal's triangle. Up to here. There's going to be 6 terms to this. We're going to have a 1, 5, 10, 10, 5, 1. We're going to start out with that first term to the 5th, which is just x. So it'll go x to the 4th, x cubed, x squared, plain old x, no x's. That negative 2 will start out with none of those. And then it'll pick one up. Then it'll pick up another. We just keep gaining on the powers. And then again, just clean this up. First one's x to the 5th. Next one's going to be negative because that negative 2 is getting raised to an odd power. And 2 times 5 is 10x to the 4th. Here, a negative is getting raised to an even power. That makes it positive. 4 times 10 is 40x cubed minus 80x squared. Let's see, 16 times 5, what is that? Another 80. X minus 32. Okay. All right, this one. Let's get our... Okay, so I'm going to have 1 of the z to the 4ths plus 4z cubed, and I'll pick up a 3, plus 6z squared, I'll have a 3 squared, plus 4z times 3 cubed, plus a z to the 4th. So, well, not z to the 4th, sorry, 3 to the 4th, duh. And then I'm just cleaning each one up individually. Let's see, 9 times 6 is what, 54? 27 times 4, can't believe I'm punching that in. 108. And 3 to the 4th is 81. How many more we got? Just the one? Okay, good. So to the 5th. Okay, so I'm going to have 1 of the 2t to the 5th plus 5 of a 2t to the 4th times a negative 1 to the 1st plus 10 2t cubed times a negative 1 squared plus 10 2t squared times a negative 1 cubed plus 5 times a 2t to the 1st times a negative 1 to the 4th plus 1 of the negative 1 to the 5th. Okay, that's 32t to the 5th. Let's see, 2 to the 4th is 16. 16 times 5 is 80, but oops, it's going to be negative 80. Let's see, it's definitely positive. The negative is going to even power. 2 cubes 8 times 10 is 80. 40t squared plus 10t minus 1. I know I went through that really fast. Like we spent a good 40 minutes discovering all this, and I just kind of went through it in 15 minutes. So let me know if you have any trouble.